Hello friends, we are bigdatahands.com. Today is day 29 at the end of machine learning. So you can see today we'll see model selection and boosting algorithms. This is the final day for machine learning actually. We started from day 15, day 15 to day 29. We covered day 29. We covered machine learning. This is the last day. And from tomorrow we're going to start deep learning sessions. Okay. So all the previous videos till day 28 I think will be uploaded in our YouTube channel. You can watch it here or YouTube channel bigdatahandson.com. And if you subscribe to our channel, you will get all the notifications. Our website bigdatahandson.com. So you can visit our website. Our contact information is here. If you have any doubts, you can message this number 978988424, or you can send email through support@bigdatahandson.com. So today topic we'll see model selections. Okay, so model selection is nothing but uh, for the for a particular data set, which model is better to choose. Okay, so to choose a model, first uh, it differs from the training the model. Okay, so we have three methods of training the model. One is training a whole model, whole data. Using the whole data we can train the model, or you can split the data set into two parts, that is training and testing. This is the second way. And the third way we have is the efficient way. So uh, to select the model we use this method only. The method is the cross validation. Okay, so I will tell you. First we have we can use the whole data for training and testing as well. So there is a disadvantage of doing this. Why? Because you are testing the data, which data you have already taught to the model. So this method will not work. Okay, the second method is training and testing, splitting the data set into training and testing. So this method actually works, but it depends on the parameters. So the parameters are test size and random state, right? So it depends on the parameters. So you need to tune the parameters, right? So in the third way we have cross validation. So first in this session we'll see the cross validation first. Okay, so we'll see the cross validation to select a best model for the data set I'm going to use. Okay, so first I will tell you what is cross validation is. And one more thing, one more disadvantage is in training and testing, splitting the data set as training and testing. That is, if you split the data set into training and testing, what happened is maybe some important data uh, can be separated into the test data, right? So if that data is in the training data, maybe you can gain your accuracy. So we have the cross validation, right? This method will work for every algorithms, uh, which accuracy is giving this by the cross validation, that is the final accuracy of the model. Okay, so we can say that, let's say we have five-fold CV. It's nothing but five-fold CV means, so when you have a whole data you want to give, and it separate as a five parts. That's what the five-fold CV is. It separate the data set into five parts, and then what happens, it run the iteration five times. Okay, it run the iterations five times, and every iterations, in the first time the first part will be used for testing, and the other remaining are used for training. Okay, and the second iteration, second part will be used as test, other remaining as training. And in the third iteration, third set used for test, and in the fourth iteration, fourth um, set is used for testing. In the final iteration, the final set is used for testing. Okay, So likewise, what happened is, if you do like this, so you are not missing any information, right? So we are splitting the parts, and we are using the every parts, right? So we are using the every data parts to train and split. So that's why this method is a very good method to select the model. So the accuracy given by the cross validation is the final accuracy for the model. Okay, so we get finally we get the accuracy by averaging these accuracies. Okay, so in every iteration we actually train the model. Actually, we we train the model and test the model using the test data, and again train the model with this data and test the model with this data, like that. And finally you will get five accuracies. Average accuracy is the accuracy of the model. Okay, so we'll do that first. I created a new file, and I'm going to save this file. To select the model for a data set, so initially what you have to do is, you have to choose the path, whether it is classification or regression, right? So the first step is what we need to decide, whether it is classification or regression. Okay, so you can easily find that, because uh, classification means the resultant variable will be classes. For regression it's a continuous, right? So what I'm going to do is, I'm going to create a file for classification. In this file we are going to do all the classification sorry, all the classification algorithms here. Classification.py. Oh, sorry. So I will import the library pandas, numpy, matplotlib, or just pandas numpy only, and import the numpy. So now in the data set, I'm going to take a data set. For that data set, I'm going to find the best model. So let's take the heart disease data set. So either I'm going to find whether that person has the heart disease or not. Okay, so we have the target variable and we have the all independent variable, right? So we need to read the data set first using the pandas read csv function. You want to give the name of the data set. So you want to give the whole path, that's dataset slash the name of the file. Okay, now we'll select this line and run this line. Now in the variable explorer you can see the data frame. So this is our data set. Okay, these are the independent variables, the target we need to find. So this is the classification, right? So we have two classes, whether that is 0 or 1. So whether the patient is affected by the heart disease or not. Okay, that's what we are going to predict. So it has nearly 303 observations. Okay, so the first part what we'll do, we'll try with the training and testing. Okay, or else we'll go with the cross validation. For that cross validation, what I'm going to do is, In whatever algorithms is in the classification, I'm going to create an object for all the I'm going to create objects for all the classification algorithms in machine learning. So the algorithms are, the first one is we know that uh, logistic regression. So that is inside the linear model. In the linear model, we'll import the logistic regression class, and we're going to create an object for that logistic regression. Let's name it as logit, and we'll call the class. That's it. So we created the model. Okay, so just the object only we want to create. We're not going to fit into the data set. Okay, and then the next algorithm will be k neighbors. So that is inside the neighbors module, and you need to import the k neighbors classifier. Okay, now we'll create let's say knn, name it as knn, and we'll call the class, and we'll give the n neighbors as, or we'll take as a default one. Okay, I'm not going to tune it, just take it as the default one. Okay, and then the next algorithm I'm going to use is the decision tree. Sorry, that is inside the tree, right? Inside the tree module we have the decision tree, decision tree classifier. Now we name it as tree equal to decision tree, and we'll use the default one. Okay, default parameters only, and then we'll try to tune. Okay, and the next algorithm is random forest sklearn dot ensemble. That's inside the ensemble model module. Inside we have the random forest classifier. Okay, so we take it as forest equal to random forest, and then the last one will be svm support vector machine. That's inside the svm module. We have the class for support vector classifier, that is svc. Okay, let's take it as support equal to svc. Okay, now we have created all objects for the machine learning classification algorithms. Now what I'm going to do is I'm going to import the cross validation. Okay, using the cross validation I'm going to test the accuracies for every uh, algorithms here. So I will take a, let's take a list of algorithms. Let's say algo, and we'll put all the algorithms here. Let's say logit, knn, tree, forest, and support the machine. Okay, and then uh, okay, first we'll try with the one algorithm, and then we'll go we'll iterate through the algorithms. Okay, so to do the cross validation, so you have to import the function called cross val score and k fold to fold the data set into number of splits. Okay, the two functions are in the model selection module. Okay, inside the module we have the classes k fold for folding the data set and splitting the data set into a number of splits, and then we'll import the cross val score. Okay, this function will give you the accuracies. Okay, so initially we want to create a fold, so call the class k fold, and you need to give a number of splits. Let's take it as 5 splits. Okay, and then I'm going to give you the accuracies. Okay, let's take it as acc, and we need to call the function cross val score, Inside, let's see what are the parameters you need to pass. Estimator is nothing but the object of the model. Okay, we have created. So first let me use the logistic, and then what parameters you want to give, x and y. So we don't have to split the data set, so you just have to give the independent and dependent variables. So the independent variable for this data is uh, all the columns except the final column, right? Yeah, except the final column, all the columns are independent. So we'll take the columns. So we'll take all the rows. The columns are starting to uh, except the final. So we'll put -1. It will give you except the -1, the last column. Okay, for the y, the column is the final column. Alright, so you can give just -1. And one more thing here, you want to give the ilog actually. Okay, now we'll pass the data set, the independent and dependent variable, to the cross val score function. Okay, now I will run this. So it will take some time because we are using too many algorithms, right? Yeah, now in the accuracy you can see that it's an array of 5 accuracies. So for the logistic regression, in the first iteration we get 81%, in the second iteration 86, and the third iteration 83, and the fourth iteration 85, and the fifth iteration 75. If you find the mean of the accuracy, that is the final accuracy of the logistic regression for this data. Okay, or I think acc dot mean, I think. Okay, so you can see 0.82. This is the final accuracy for the logistic regression on the heart disease data. Okay, so likewise, so we have done for a single algorithm. Likewise, we iterate through the algorithms and we'll find the uh, accuracies for the algorithms. Okay, so to do that, we'll iterate through the algorithms. So it's for, let's say, model in algo. Okay, and okay, we'll copy and paste it here. Okay, now uh, it comes inside the for loop, and the same, take it as the same, but here you have to change, instead of log it you have to change the model. Okay, because we are iterating through the algorithms. So in the first, the logit will come, and the next kn will come, and then tree, and for us, and then support. So like that. Okay, and then it will print for every algorithms, it will print the accuracies. So for more informative, you can give model comma acc.me. Okay, now let's run this code. So you can say for k neighbors we got 64%, for decision tree we got 76, for random forest 81, svc we got 64. That's the logistic. Okay, so let's try to tune the parameter of the models. Let's say n neighbors equal to, let's say, three neighbors, and the decision tree. What are the parameters we have? The criterion, right? Criterion we will use Gini index. Criteria, okay, default one is Gini index. What we can give other, okay, nothing else. In the random forest we have, so you can give the number of estimators. N underscore estimators is default 10. Okay, we'll increase it 20, and criterion Gini index same. Okay, on the SVC, what are the parameters we have? Let's use a kernel equal to RBF. Okay, and we'll select the gamma equal to 0.001, and let's give the C as 10. Okay, so now let's run this code. Sorry, gamma, that is. Okay, so you can see for logistic 82%, for KNN with the three neighbors that's the same 61 what we get previously. So in the addition tree it increases, it's giving 75, and random forest gives 0.80 80%, and the SVC gives 63%. I think the kernel is not working, I think. So we'll try to change actually. So likewise, what you need to do is you need to tune all the algorithms, and you need to find the best algorithm for the, as in this step. Till now you can see the logistic regression gives the high accuracy, right? So for this model, so we'll select the logistic regression like that. We'll tune the parameters, and we'll select the best model for the data set. Okay, using the cross validation we have done. Okay, right. Okay, so now what we're going to do is we are going to do it for regression as well. Okay, so we'll create a new file, we'll save it as regression. Let's take a regression data, and then we'll do it for the regression data. Okay, real estate maybe. Yeah, we'll use this one, real estate. The same will do it for the regression as well. So we'll import the pandas as PD, and we'll import again the numpy, and we'll create the data set using the function pd dot read csv. Okay, you want to give the path, that's data sets slash the name of the file. Okay, now we'll run this code, we'll get the data. Okay, let me remove all the variables from the environment, and then we'll run again. So now we got the data frame. So here in this data set, what you are going to predict is you're going to predict the price of the unit, okay, with the given independent variables. These are the variables we have given. So you need to find the price of unit area. This is what we are going to predict. Okay. So initially in the first column we don't want, so we'll split the data set independent and dependent. So we'll select the independent variables, all the rows, but the column is from starting, not starting. So we'll ignore the number column. Okay, index column. So we'll start with 1. Okay, that means we are starting with the second column, and until the last one we are excluding the last column as well. That's why we are giving -1. Okay, so for the y it is a -1 column, the last column. We'll put -1 dot values. Okay, so now we are going to import all the I'm going to create an object for the regression algorithms. So first is the linear regression. We'll import the linear regression. We'll create a model, linear, and the next model I'm going to use is the k neighbors regressor. That's inside the neighbors module. K neighbors regressor. Okay, so we'll create the object for k neighbors. Okay, and then for decision trees also, uh, tree decision tree regressor. And for the last one is SVR. We are going to use SVR. Now we'll copy the last 5 lines from this. So we are going to do the same one here, because that's why. Let's run this program. Wait. Okay, we given capital X. That's okay. So now for linear we get 58, k neighbors 63, decision 348, random forest 70, SVR 50. So again we can improve the accuracies by tuning the parameters. So till now the best model is random forest. Okay, so we got 0.7%. Okay, 70%. Okay, so this how we select the best model for the dataset. Okay, so now we'll go with the next topic, that is boosting. So this is the final algorithm we are going to see, XGBoost. So what is XGBoost is? XGBoost is an algorithm that is dominating nowadays. So it's because you don't have to do anything. It automatically try to improve the performance of the algorithm using the boosting method. Okay, so we'll see what is boosting method, and uh, bagging method also. Okay, so XGBoost is an algorithm that has recently been dominating applied machine learning. XGBoost algorithm is an implementation of gradient boosted decision trees. So in XGBoost also we'll use decision trees as well. Okay, so in decision tree, using the decision tree, we have three methods actually. One is ensemble, another one is boosting, and the last one is gradient boosting. So in ensemble we have done actually, ensemble means combining one or more sorry, two or more algorithms uh, to create a single algorithm. Okay, like the random forest. In random forest, what we do actually, we'll create many sorry, multiple decision trees, right? So we'll combine the multiple decision trees and in a single decision tree. So a single to get the single result. Okay, so like that, that's the first method, ensemble. And another method is boosting. Okay, boosting, in boosting, what you do actually, we'll use a decision trees, the same concept in ensemble, but we improve the decision trees by the errors of the previous decision trees. But we don't do in the ensemble method, because it's parallelly running all the decision trees. But in the XGBoost, it will run one by one. So boosting means it will run one by one. So first decision tree will run, and in the next decision tree it will try to improve the errors of the previous decision tree. Okay, that's the method of boosting. Okay, so basically XGBoost is a type of a software library. So you have to install it. This is a type third party library you have to install, and that you can download and install on your machine. Then you have to access it from a variety of interfaces. Okay, so first we'll try to download and install it. So open up a terminal or command prompt in Windows. Okay, and then you have to type this command. In my case that is pip3 actually. In your case maybe that's pip itself. So pip3 install XGBoost. So it will download and install the library. So it takes some time. I just forgot to activate the Conda environment, so don't do that. First activate the Conda environment and then do it. Sorry, Conda activate, and now run the pip install XGBoost. I just forgot that, because you need to install the XGBoost algorithm on a Conda environment, not the default environment. Okay, okay, it's huge actually, 157 MB. Okay, actually it's not like a random forest. It runs fast actually when compared to random forest. And so after installation you can use this algorithm. So let me continue with the slides. So in the next, we'll go to the next slide. So now we have the bagging method. So what is bagging method? So while decision trees are one of the most easily interpretable models, they exhibit highly variable behavior. Okay, in the decision tree, if you create a decision tree model, it gives you a high variance result, because it tried to overfit the data set. So that's what the main problem in the decision tree, right? So so consider a single training data set that we randomly split into two parts. Now let's use each part of each part to train a decision tree in order to obtain two models. Okay, we're training two models here, and then when we fit both these models, they would yield different results. That we note, right? So in decision tree, will it gives a different results for different data set are said to be associated with high variance due to this behavior. Bagging or boosting aggregation helps to reduce the variance in any learner. Several decision trees which are generated in the parallel from the base learners of bagging technique, data sampled with replacement is fed to these learners for training. The final prediction is the averaged output for the learners. This is the bagging method, and here we have the boosting method. So boosting method I have said before. So like running one by one. So running the first decision tree and then running the second decision tree, it will try to improve the errors of the previous decision tree. Okay, in boosting, the trees are built sequentially, okay, such that each subsequent tree aims to reduce the errors of the previous tree. Each tree learns from its what is this predecessors and updates the residual errors. Hence, the tree that grows next in the sequence will learn from an updated version of the residual. And the base learners in boosting are weak learners in which the bias is high, and the bias is high means the error is high. Actually, the first, the weak learner, that's simply like guessing. It has a guessing power only. It's a random guessing. Okay, so and each iteration will try to improve the tree. Okay, and the predictive power is just a tad better than a random guessing. Each of these weak learners contributes some vital information for prediction, enabling the boosting technique to produce a strong learner by effectively combining these weak learners. The final strong learners brings down both the bias and the variance. Okay, this was the boosting technique. Uh, that's applied in the XGBoost algorithm as well. Okay, so we can see we have installed successfully. So now you have to go the spider and we'll create a new file. Okay, we'll save it as xgboost.py. We take the same algorithm, we'll take the same data set here, our disease. Let's see how the XGBoost is working on the heart disease dataset. Now we are going to split the dataset from sklearn dot model selection, import train test split. Oh, we have, oh, it doesn't split into independent and dependent variable. We take it as independent and dependent variable, and then we'll split the dataset. That's x underscore train equal comma x underscore test y train y test. So now we split the dataset into training and testing. Okay, so we have the training and testing dataset now. So it's time to create the model. Okay, so to okay from XGBoost. So we have installed this library. Now inside the XGBoost we have the class called XGB classifier. It's not coming. it's not showing the options. Yeah, no, it shows XGB classifier, and we have XGB regressor as well. So this was the class I want. And you have to create the object for the class or XGB X classifier. Okay, and now we need to fit the model into the data set. Fit into training x underscore train y underscore train. Okay, so now we'll fit the data set. Cannot import name xgb classifier from xgboost. Okay, I think I need to change my uh, file name. That's the reason. Okay, we'll name it as capital X. Okay, so now you can see it's running. So we have fitted the XGB classifier into our dataset, training dataset. Now it's time to predict. Y underscore pred equal to boosting dot predict. So this is the prediction, and this is an actual. So you can count the correct and incorrect predictions using the class, using the function. It's inside the matrix. We'll create the confusion matrix using this function. And in the confusion matrix, you have to give the white test, that's the true value, and the predicted value. Now you can see the confusion matrix here. So 8 plus 9, 17 incorrect predictions, 25 plus 34, 59 correct predictions. That means, so how many we have? 59 divided by uh, totally we have, how many we have? The X test 76. Oh, 76. Over the 76, 59 is correct. So the final accuracy we have gain is 0.77. Okay, so you can print the score, the function score, I think. 0.77. Maybe you have to tune the test size and random state. You will see 0.78. So we got 0.81% accuracy. Okay, so leave it. So this is how the XG boost is working. So we have So on how to select the models for the data, and we have seen the boosting algorithm. I think we have another algorithm for boosting also, that is I think ada boost. So you can search it in Google, ada boost. It's also in boosting algorithm like XGBoost. Okay, so we now end this session. So you have any doubts, you can ask now. Any doubts? Any doubts you have? So it's the final day for machine learning. So you can ask any doubts on the machine learning. So you have seen previously. Okay, I think no doubts. So we are bigdatahandson.com, our website bigdatahandson.com. So if you have any doubts, you can message in this number 9789844, or you can send email to support@bigdatahandson.com. Our previous videos will be uploaded in our YouTube channel bigdatahandson.com. If you subscribe to our channel, you will get all the notifications. Okay, from tomorrow we'll start deep learning. So you can see day 30. Day 30 will see introduction to deep learning and artificial neural networks using Keras, and then day 31 convolutional neural network, day 32 recurrent neural network, day 33 will do the same like artificial ANN, CNN, RNN with the use of TensorFlow. Okay, so that's the three classes, 3 days. Okay, and then we'll do some algorithms like autoencoders, generative adversarial network, transfer learning, object detection, recommender system. So from day 30 to day 40, that is deep learning. So we'll see tomorrow. Bye.